Okay, so for step one, we need a couple resistor values. And I don't have the exact resistors, so instead of a 330 ohm, I'm using a 360 ohm. Instead of 1.2 kilo ohm, I'm using 1 kilo ohm. And instead of 3.3 kilo ohm, I'm using 3.6 kilo ohm. So let's see what they actually are. So for the 360 ohm, we're getting about 350 ohms. Not mix them up. $352.1. Now for 1 kilo ohm. $984 ohm. And now the 3.6 kilo ohm. $3.533. Kilo ohms. Alright, that's it for step one. The rest are just calculations. Okay, so let's build this circuit right here. Now, the linear voltage regulator that's going to be provided is in a package like this, and since I don't have the actual board to build this on, I'm going to have to improvise, and I'll probably just use the breadboard for now. Now, one thing you might notice is there's 3 pins here, and it looks like we're using a op amp here. You know, we have negative reference, positive reference, inputs, outputs, but we're going to be using this. So what you're going to want to do is you're going to want to flip back to your reference diagram in page, I guess that's II5, and it'll actually tell you input, output, and adjust on this chip package. And if you come over here back to the page we were at, you can actually kind of reverse and figure out where this chip is going to go and where the leads are going to go. So you have your input, output, and adjust. This is going to probably be your input. This is going to be your output. And then this one right here is going to be your adjustment. So that's how we're going to orient this chip, and we'll see if it works correctly based on that orientation. And unfortunately, it's going to be a lot of turning back and forth because the diagram's right here, and all of our test probes are in here, but hopefully we can wire this up in a way where we can just power through it. So let's get going. We have our transformer, rectifier, and just a smoothing cap right here. I'm leaving the 10 microfarad capacitor in because it has the best smoothing that we tested previously in the lab. Now we have this going something like that, and we're going to have our input lead going positive. Let's see. Okay, so the input is going to be this far pin right here. It might be easier if I just bend these pins so you can see it a little bit better. Alright, so your input, I'm just going to say, is over here, voltage in. And now we have our output. That I'm just going to stick all the way over here on the edge of the board. Now we need some leads going for the testing resistor right here, and that value is actually going to be changing between 0, 1.2, and 3.3 kilo ohms. So we might as well break that out further out in the board, just to make our lives a little bit easier when testing. Alright, so we're going to go between the output and the adjust, which is this last. Fix that. So let's check to make sure I didn't mess anything up. We got your input, which is the first pin. Here's the power input, first pin. Then we have our output, which is our second pin. That's going over here. And now this wire is going to be between the output and the adjust. Let's go to the adjustment pin, which is the last pin. Let's just move it all the way over here so it's easier for us to reference. And let's make our another lead. Okay, so we have our adjustment line, and then we have our output line, which our output line is in the middle. So now these two are going to be our adjustment test resistor, and now we have a resistor that's going from the adjustment side to ground, and that's going to be this 330 ohm resistor, and we're just going to pick the first resistor that we tested before, that way we don't have to remeasure it. So that's going between adjust and ground. And then our output is simply just going from ground to the output, which is all the way over here. But let's just add a ground wire just so it's easy for us to test. Okay, so looks like that's pretty much all we need. We have our linear voltage regulator, and then we have our little testing resistor area, and then we have our output. And let's see how this goes. Okay, so let's get a test lead here so we can short this out and make the resistance essentially 0. And let's plug it in. Just for fun, let's see what it is with no resistance. Well, open resistance. 13.22 volts. Not warm. Okay. So let's short it out and see what happens. .376. Let's just say 9.35 volts. All right. So let's measure the voltage across this resistor, this little load resistor for the reference. Let's see, it's going between there and ground. 9.27 volts. All right. Now we're going to replace this short with a 1.2 kilo ohm resistor, but for us that's a 1 kilo ohm resistor. And I believe that's this one right here. Let's just verify that real quick. Yep. And let's see what the output voltage is. .79 volts. Now that's for calculations on the other page. And let's do the same thing, but with the 3.3 kilo ohm resistor. 4.26 volts. Alright, same thing with the percent difference. We'll use our calculations we had before. Measure the temperature in Celsius. Alright. Watt resistor. I think I am going to have to come back and look for some higher wattage resistors. Alright, so it looks like I'm going to have to just make these resistors. It's not hard to do. We all know how resistors work, so we'll just make a couple of bigger resistors with smaller resistors, so it can handle more current going through them without blowing them up. Well, frying them. They won't. Well, they might blow up. Who knows? They usually just fry. Alright, so this resistance, 444 ohms, and really, well, I guess we didn't need to make a big resistor for this one. So let's see. Okay, we did that. It's right there. And 1.2 kilo ohm for our test. Let's just verify. All right. So now we have our nice big resistor here that can handle a decent load now. And we're going to have to find the current out and the voltage out of this. Let's do voltage first, because this is going to have to warm up some, I would assume. Just say 1.74 volts. All right, now current. 4 milliamps. All right. Skip that one. Just reconnect the load. Okay, measure the voltage of the input. Which is going to be up here. .26 volts. Gonna skip calculations, Measure the temperature of the room. This should be nice. Let's see how well this thing works. Let's just pick the I don't know if you can read that. Let's just say 20.9 degrees Celsius. Alright, well, let's measure the temperature of the chip. .4 degrees Celsius. Alright, then the rest is just calculations. So that wasn't too difficult. Now, see you in the next one.